Hey guys, welcome to part 2 of today's glacier video, and this is going to focus on glacial deposits. So what we're talking about is the material that the glacier leaves behind once it's eroded it and carried it to wherever it is going to go. This is incredibly important for us here in New York because a large amount of the downstate area, Long Island, New York City, and places like that have been directly shaped, formed, and deposited by the glaciers that covered us throughout the last few ice ages. Specifically, the last ice age ended about 11,000 years ago, and we can still see the effects of it here. So we're going to talk a lot about stuff that you can actually see here on Queens and Long Island and New York City. And so please pay attention, and I hope you like it and enjoy it. All right, guys, let's go. All right, so when we're talking about glacial deposits, we're talking about the material that gets left behind by a glacier. Typically, the term that we use to describe this is what we call glacial drift. That's any sediment that a glacier happens to leave behind. So when we're talking about this, there's actually not just one type of drift. There's actually two main types of glacial deposit or glacial drift. The first type is what we refer to as till. Till is material that gets directly deposited by the glacier. So if you imagine the glacier as the example that we talked about of the snow shovel. So the snow shovel pushes forward, that's the glacier. Whatever material the snow shovel physically touches and physically moves and drops off, that would be the till. So the pile of stuff in front of it. The second type of glacial deposit is what we call stratified drift. Stratified drift is the material that gets deposited by the glacier as it melts. Well, as the glacier melts, it's going to produce rivers and streams. Whatever material gets washed down with that water and gets deposited some distance away from the front of the glacier by this melt water. Melt water is the water that melted out of the glacier. We call that stratified drift. Now, when we look at till, if you look at the picture in front of you right now, you will actually see till on the left side and stratified drift on the right side. The thing about till is not sorted in any way, shape, or form. You will have pebbles, you will have cobbles, you will have boulders, you will have sand, you will have silt, you have clay. You will have pieces of all different sizes, all jumbled up in a mess. It's just a big pile of whatever the glacier managed to pick up, dropped off. There's no organization to it. It's not neat. It's not organized. That is one of the defining aspects of till that you should be writing down. Till is unorganized. It is unsorted. It is just a jumbled mess of whatever the glacier managed to grab while it was moving. Stratified drift, the term stratified should be different. Stratified drift, since it's formed by the flowing of water, if you look at the right-hand side of the picture, you see the layering. And this is exactly what's going to happen. The biggest, heaviest stuff is only going to be able to be carried by the water when it's moving super fast. So it's going to be dropped off first. And then the medium-sized stuff is going to be dropped off later. And then the small stuff is going to be dropped off last. And so stratified drift tends to be much more organized than till. Okay? Now, this is going to be incredibly important. Long Island, a large chunk of Long Island is actually made up of till and stratified drift, okay? And we'll talk about what that is in a little while. Now, there is one other thing that we can and sometimes do find with deposits, and that's what we call an erratic. An erratic is spelled E-R-R-A-C-T-I-C, an erratic. An erratic is a large boulder that is just dropped off in the middle of nowhere. You can see one in this picture right here. You can also see one in the next picture that's popping up. And the reason that it's called an erratic is because it is a type of rock that should not be there. For example, you'll have an area where the bedrock is all, let's say, gabbro. Tons and tons and tons of gabbro. And you find a gigantic boulder of granite. And that granite, when we look at it, came from mountains or hills that were hundreds of miles away. How the heck did it get here? It doesn't belong there. It is erratically placed there. The rocks that you're seeing in front of you, the one that you're seeing right in front of you right now is from Central Park. You find these all over the place. These are weird boulders that are just perched on top of other rocks that don't belong there. These are called glacial erratics. These things weigh tons in some cases. The only thing that could move them would be something much bigger and much stronger than them. So something like a glacier. Some of these rocks would have been lodged inside of the glacier. Some of these would have been pushed forward by the glacier. And when the glacier melted, it just dropped them wherever it was. The glacier could push them, but once the glacier stopped being there, no more energy. Therefore, you just drop it off wherever you happen to have it. Really important one, and this is primarily a deposit of till, is what we're talking about, is what we call a moraine. So a moraine is basically, it's a ridge of till. It's a hill of till. It's a pile of till that's been dropped off by the glacier. Now, there are four main types of moraines. We have what we call lateral moraines, medial moraines, end moraines, and ground moraines. We also have something called a recessional moraine, but I'll explain what that means in a minute. Okay, so make sure you copy these terms down, and we're going to explain what each one is. Now, when we look at it, here you have a glacier. Okay, the till is going to be this stuff that you see down here. This is all the sediment and all that stuff that's being carried. Some of it can turn into stratified drift if meltwater gets it. Okay, but the stuff that you have here, this is going to be all the eroded material that this glacier is dragging down with it. Now, as that glacier drags down the material, eventually it's going to melt and it's going to drop all that stuff off. You can see how this is till because none of it is sorted. You've got boulders, you've got pebbles, you've got cobbles, you've got sand, you've got silt, you've got clay, you've got all sorts of stuff in this picture that's all disorganized. There's nothing that is stratified, there's nothing that is organized by weight or by size. So this would be a field of till. Okay, this would more than likely probably be part of a ground moraine, the stuff that was underneath the glacier. So if we're looking here you have an actual glacier, a drawing of one anyway. And if we look here, what you've got is you've got lateral moraines. Lateral moraines are going to be on the outside part of a glacier. So you see this glacier here, this would be the tributary glacier, right? So this would be a lateral moraine, and so would this. This is a medial moraine. Medial means middle. Lateral means on the outside. Think like football plays. When you lateral the ball, you throw it to the guy next to you. Okay, now sometimes you see the glaciers merge like this, and so what can happen is you can get moraines in one glacier that are one thing and then another one they are another one. But that's not the big deal. So here, if we look at the main glacier, which is this guy here, you see you have your lateral moraine. So lateral moraines are going to be the moraines that are on the outside. Think of when you're pushing a snow shovel forward, think of the snow that piles up on the outside parts of the shovel. Okay, those would be your lateral moraines. Okay, now when you get to the glacier, as far as the glacier is going to go, okay, the spot where the glacier ends is going to be your terminal moraine. That is the furthest that the glacier ever extended. It pushed all that debris up in front of it and dropped it off. Once it dropped it all off right there, that would be your terminal moraine. Now, what starts to happen to the glacier? It starts to melt. You can actually see the water going on here. Okay, and what happens is as the glacier melts, it's going to drop off whatever material was inside it, underneath it, or this, that, whatever. Okay, and we call those end moraines. Those are those big ridges, those big hills. In between them, you get the ground moraines. The ground moraine is like the picture that you saw before. It's all the leftover debris that was like stuck to the bottom of the ice. Think of when you shovel snow and there's like the leaves and the pebbles and the sand and the stuff that was stuck to the bottom of the snow. That stuff just gets dropped off when the snow melts. That would be your ground moraine. Okay, and then every time that the glacier melts a little bit, you get these recessional moraines, and it shows you the process of how the glacier was slowly recessing. Okay, now these pictures, what these show you is some moraines that you find in the Midwest of the United States. All of these red lines represent different end moraines for different glacial events that happened in what we call the Wisconsin age. The purple ones represent the Illinoisan age. Now, who the hell cares about the Midwest? What we care about is where we're from. We're from New York. And in New York, if you've ever seen these things, these rock walls floating around, these are actually probably a pile of till. They're either erratics or till that were dropped off by the glacier that was here. The last glacier that was here dropped off a moraine, an end moraine, a terminal moraine that we call the Ronkonkoma moraine or the Harbor Hill moraine. Okay? And these lines directly show you how far south the glacier went. So imagine all of this up here was covered by a massive continental ice sheet glacier, and it stopped right here. Now, for those of us in Queens, New York, there's something that should be particularly important to this. This line right here runs along a major road throughout most of Queens. It runs along Hillside Avenue. And if you think about it, okay, think of Queens north of Hillside Avenue and Queens south of Hillside Avenue. North of Hillside Avenue, it tends to be very hilly and very bumpy. The North Shore of Long Island tends to be very jagged and very bumpy. Lots of hills, lots of, roads that go up and then roads that go down. You have a lot of elevation, a lot of change in slope. Why? Because everything north of Hillside Avenue, everything north of this terminal moraine here is just piles and piles of till, ground moraines and things like that, and recessional moraines that have gotten dropped off as the glacier slowly melted and worked its way back up toward the North Pole. But everything south of Hillside Avenue, if you think about it, is incredibly flat. Belrose, Jamaica, Springfield Gardens, okay, Howard Beach, Okay, if we think of those neighborhoods, you don't have a whole lot of elevation. Those towns are really flat. And why? Well, because everything south of here is no longer till, it is stratified drift. So if you look, almost all of Long Island, which is where we live, is primarily made up of either stratified drift on the south shore or till on the north shore. And as you guys will learn, the north shore and the south shore of Long Island are very different in a whole lot of different things. One of the biggest things is the type of ground that you have. The next type of glacial deposit we're going to talk about is what we call outwash. Now, outwash is exactly what it sounds like. It's the material that gets deposited as the melting ice inside the glacier washes out across the end moraines. So imagine you have a glacier like the picture that we saw before, and the water is coming out of it. Well, as that water comes out of it, it's going to run over the moraines, and it's going to pick up material from that moraines. Remember, the moraines are till, so they've got everything: cobbles, boulders, sand, silt, and clay. Okay, and that stuff is going to get carried downstream, especially if you have a slope or anything to go with you right there. And so it's going to carry that material downstream, and as it carries that material downstream, it's going to deposit it based on side, creating stratified drift deposits. Now, this area just past the end moraines, where you start to deposit your materials that you picked up as the water is gushing over, as that melt water is gushing over the moraines, is what we call an outwash plain or a valley train. Now, it usually tends to be very flat, and it just consists of layers of sand and silt and clay, very small sediments that get deposited by the water. Remember, this stuff is organized by weight, so the heavier stuff is going to get dropped off first, followed by the medium-sized stuff, and eventually the very light stuff. So this light stuff tends to stretch out. This is actually what we see on the south shore of Long Island, Brooklyn, Queens, Suffolk, and Nassau. Okay, the southern portion of it tends to be very flat. Think of the North Shore versus the South Shore. Where do we find most of the beaches that we like to go to in our general area? We find them on the southern chart. Coney Island, Jones Beach, Robert Moses, places like that. The northern part, College Point, if you think of parts like that of Queens, if you think of the rocky parts of like Great Neck or places like that in Nassau County, the beaches there tend to be chock full of rocks and stuff like that, and not a whole lot. Why? Because that's either going to be directly under the glacier or very close to these drumlins, to these moraines. Sorry. So if we look at the picture in front of us right now, you can actually see this process happening. Okay, you've got a glacier on the upper left-hand corner of the picture, and you can actually see the moraine, the big pile of dirt right in front of it with the little hole in it. And that hole represents meltwater coming out. That's water gushing out of that moraine, and it's carrying all the debris that you can see fanning out into a fluvial deposit that you can see in front of you. Okay, now given enough time, what you're going to end up with is just this very flat layer of material just out in front of the glacier, just like you find in southern Queens. One of the actually more interesting ways that you can tell if a glacier did exist over a place where you are standing is by looking for what we call striations. Striations are just scratch marks. They're these scratch marks that are produced by a glacier as it drags quarried or plucked sediment across bedrock, and it leaves these deep gashes, these deep scratch marks all along the bedrock that it scratches, like you can see in the picture in front of you. Those scratch marks were not there originally in the rock. They were produced by a glacier dragging quarried rocks. We find these a lot in New York, and in fact, the picture you're looking at right now was a picture that I took when I went to the Bronx Zoo with my kids last year, and I noticed these rocks. You can see these scratch marks. See how they all go? They're parallel scratch marks. They're not disjointed. They're not random cracks or breaks. They're actual scratch marks, and this indicates that a glacier was dragging stuff across here. As you guys walk around, if you walk around New York City and you see you see bedrock, you should look for these marks, and that'll give you an indication that there was a glacier where you were standing. Another important feature that you get from glacial deposits is what you call a drumlin. Now, drumlins are basically just hills of till that look like teardrops. They have one steep side and one pointed side. The steep side tells you the direction that the glacier was coming from, and the gentle side tells you the side that the glacier was. One of the other things that glaciers tend to form are lakes. Example of this are finger lakes. Finger lakes happen when a glacier dams a stream valley, deepens it, and forms lakes that look like little fingers. You see this in upstate New York on page 3 of your reference table, and you see them all the time. Another type of lake that you can form is a kettle lake. And this forms as ice gets stuck in that outwash, leaves a depression, melts, and makes like a bell-shaped lake. And you can actually see this on Long Island if you go out to Lake Ronkonkoma, which is on the LIE at about like exit 50.